Now, let us try to understand regarding the angle between any two vectors. So, next is all about your angle between vectors. In order to represent the angle between any two given vectors, let us suppose the vectors, this is vector 1 and here it is your vector 2. So, always remember that in order to find the angle between two vectors, first of all, identify a point. And from this point, let us draw two different vectors. Point, this vector and another vector shifted parallel to itself. So, whenever these vectors start from a point and move away from that point, such that the two tails of the vector, so here is, this is called as tail of the vector and this is called the head of the vector. Here tail and here head. Such that two tails of the vector join together, then the angle between the two vectors is measured. Okay. So, angle between the two vectors can be measured such that from a point, if the tails of the two vectors start from a point and move away from the point, then the angle between the two vectors is taken into consideration. But the same thing, if you suppose that this vector like this, if it is drawn. So, at this point, one tail is starting and another head is ended. So, we can't consider the angle between the two vectors as something like this. Absolutely wrong. So, how angle between the two vectors can be represented? Angle vector between the two vectors can be represented only when the two tails of the vectors are joined. Suppose if one head and another tail is joined, you can't take this as an angle. So, how to take the angle into consideration? The angle, its extended part, the angle between the extended part can be taken into consideration. So, meanwhile, I would like to explain you something else, children. So, consider two vectors, vector 1 and vector 2. So, earlier I told you that the two tails must join from a point and the smaller angle between the two vectors is taken as the angle between the two vectors, smaller angle, children. But instead of this, if two vectors, if it is taken like this, joined head to head, if the two vectors are joined head to head, then also the angle between the two vectors can be taken. Whether they join head to head or whether they join tail to tail, angle between the two vectors gives the same result. Okay. So, let me explain you properly. So, that same thing if you brought it. So, if you measure this angle as something like this. Yes. So, whatever is the angle between them, the same angle you will get it here. Okay. So, whether you join tail to tail or head to head, you will get the same result. Clear, children? Well, then what if one head and tail is joined? The angle between its exterior angle, so something like this, if you consider, if you extend this line, something like this, then the angle between the two vectors is nothing but the head to head. So, this can now give you the angle, but not this. This can give you the angle between the two vectors because head to head is joined. But the same if it is joined here means this angle can be different. So, how to measure the angle between the two vectors? Angle between the two vectors can be measured if either the tail to tail must join or head to head must join. The smaller angle between those two vectors will give you the angle between the two vectors. Okay. So, now let us try to understand orthogonal vectors. What are meant by orthogonal vectors? Two vectors are said to be orthogonal Two vectors A bar and B bar are said to be orthogonal if angle between the two vectors is 90 degrees. How much is that, children? Angle between two vectors must be equals to 90 degrees. Let me explain you with an example. So consider an vector, one like this and another like this. So how much is the angle between the two vectors, children? 90 degrees. Let this be A bar and this be B bar. So any two vectors whose angle between them is 90 degrees, then we can say that the two vectors are orthogonal vectors. Next to that, let us try to understand what exactly is your orthogonal unit vectors. Orthogonal vectors, orthogonal unit vectors. The vectors I cap, j cap and k cap, three unit vectors which are mutually perpendicular to each other. Suppose if you consider x-axis, y-axis and z-axis. Consider three mutually perpendicular axes. One is x-axis, y-axis and z-axis. Unit vectors I cap, j cap, k cap represents the orthogonal unit vectors. I cap, j cap and k cap lie along the x-axis, y-axis and z-axis respectively. So these vectors I cap, j cap and k cap are called as a orthogonal unit vectors, and always remember that I and j are perpendicular to each other, j and k are perpendicular to each other, whereas k and I are also perpendicular to each other. Their main property is to represent the direction. For example, if you consider 3I cap, what does that represent? It is A bar is equals to 3I cap indicates the magnitude of A is 3 and it is on the positive x-axis. It is on the positive x-axis. So something like this, 0, here it is 0, 1, 2, 3, 4, 5. So I cap indicates that this vector is taken along the x-axis. And how much is that? The length of the vector is 3. So this will be something like this. This is a vector parallel to x-axis and whose magnitude is 3. I cap indicates that it is parallel to x-axis. J cap indicates that it is parallel to y-axis. K cap indicates it is parallel to z-axis. Same thing, suppose if we are given one more vector, say B bar, which is equals to minus 5 j cap. How much is that? Minus 5 j cap. Its value is nothing but B bar can be written as 5 times of minus j cap. Minus 5 j cap or 5 times of minus j cap both indicate the same. So what does it mean? A vector whose magnitude is 5 and which is lying on the j cap indicates y-axis, minus j cap indicates negative y-axis. So something like this. If this represents a positive y-axis, then this must represent a negative y-axis. So we must consider a vector whose magnitude is 5 and this is my j cap means here it will be minus j cap. So you have to represent a vector whose magnitude is 5 and which is lying on the y-axis, parallel to the y-axis. So the vector must be something like this. So this indicates your minus 5 j cap and this indicates your 3 I cap. This is how orthogonal unit vectors are represented. Helps us. Okay, so you understood what are orthogonal vectors. What are orthogonal vectors? Vectors, if the angle between any two vectors is 90 degrees, the two vectors are said to be orthogonal vectors. But whereas I cap, j cap and k cap represents the unit vectors along x-axis, y-axis and z-axis. So, these I cap, j cap, k cap themselves are called as your orthogonal unit vectors. Okay, children. So, now let us try to understand something about your Cartesian coordinate system. So, next is all about your Cartesian coordinate system. So, what is a Cartesian coordinate system? So, suppose if you want to represent the motion of any object, if you want to represent the motion of any object with respect to the observer, you need to have a coordinate system, and this coordinate system is called as a Cartesian coordinate system. This Cartesian coordinate system generally consists of three mutually perpendicular axes. One is x-axis, y-axis and z-axis. All x, y, z axis will be lying perpendicular to each other. X-axis, y-axis and z-axis. So, this is x-axis, y-axis and z-axis. In order to specify the motion of any object with respect to an observer, we need three mutually perpendicular axes. In this case, x-axis, y-axis and z-axis, all the three are mutually perpendicular to each other. Okay, so this itself is called as your Cartesian coordinate system. And one more thing to let you know, children, in this picture, you can see that for any point P, and this is the origin and this is a particle P and this is the position vector. Position vector will be explaining in detail. So, in order to observe the motion of this person with respect to an observer who is at O, then he has to identify the distance, how far is he from x-axis, okay, how far is he from x-axis, how far is he from y-axis. This is a plane, children, this is a plane containing how far is it from y-axis, how far is he from x-axis and how far is he from z-axis, okay. So, this is how, after knowing all the values x, y and z respectively, we can identify the motion of a given object.